Okay, so when you picture a massive construction project, what comes to mind? You're probably thinking about cranes, steel beams, maybe giant concrete mixers, right? But the most critical, high-stakes part of any build, it isn't what you see going up. It's what's already there, right under your feet. And that hidden element, it holds the biggest risk of all.
So let me ask you, what do you think is the single biggest risk? Is it the budget, the timeline, the weather? I mean, sure, those are all huge factors, but they often spiral completely out of control because of one fundamental, hidden unknown.
And yeah, you guessed it. It's the ground itself. The soil, what it's made of, how stable it is. This is the one variable that can absolutely make or break a project before a single shovelful of dirt is even moved. It dictates everything. And for decades, trying to understand it has been a huge problem.
And that brings us right to the core of the issue. The traditional system for figuring out what's in the soil is, and you have to appreciate the irony here, quite literally stuck in the mud. For decades, it's just been this slow, manual process that really hasn't changed at all.
See, the way it's always been done is you get this thing called a geotechnical report. A team has to physically come out to the site, take a bunch of soil samples, ship them off to a lab, and then you wait. It's a super necessary step, to avoid total disaster, but it has always been a massive bottleneck. And the difference here is just staggering. We're talking about 2 to 4 weeks of waiting, costing you thousands of dollars just to get the basic info you need to plan a foundation. Those weeks translate directly into project delays, holding costs, and this crippling uncertainty that can cause budgets to just explode.
But what if you could just collapse that entire timeline? What if you could take that critical multi-week waiting game and shrink it down to a single moment? Well, this is where the entire process gets completely turned on its head.
Weeks, down to seconds. Think about that. This isn't just a tiny improvement, it's a complete game changer for a core industry workflow. And it's all powered by a totally new way of processing just enormous amounts of data.
So what do you get in those few seconds? You get an instant, incredibly detailed report for literally any property address in the US. We're talking real, actionable intelligence that tells you about foundation risk, whether the land can even support a septic system, what its potential is for landscaping, and a whole lot more.
But here's the really crucial part. This revolution isn't just about being faster. It's about being profoundly more accurate. It's like going from a blurry old black and white photo to a razor-sharp 4K understanding of the land.
I mean, just look at the difference. On the left, that's the old way, a traditional soil map. It's broad, it's regional, and it's often based on surveys that are decades old. On the right, that's the new approach, a super precise grid laid right over the exact property, giving you pinpoint data for that specific spot.
Let's just break down why the old way was so limited, right? First off, county-level averages are just that, averages. They can't tell you if one corner of your property is solid rock and the other is basically a swamp. Second, they are completely blind to any man-made changes, like if someone brought in a bunch of fill dirt. And third, they're static snapshots in time, sometimes from 50 years ago. They miss how the ground has changed.
This new technology tackles all 3 of those failings head-on with 3 major upgrades: a massive jump in resolution, the ability to detect stuff you can't even see, and a shift from old static maps to dynamic, continuous monitoring.
Okay, first, resolution. By going from that fuzzy, county-wide data to a precise 10 by 10 meter grid, you're boosting the data resolution by 25 times. That means you're seeing the specific conditions of your exact build site, not just some regional guess. Next up, it detects the unseen. This is where it gets really cool. Using advanced satellite tech like SAR and LiDAR, the system can analyze the ground's texture and slope with incredible precision. This lets it spot man-made changes like areas of backfill that are totally invisible on old maps, but could be absolutely catastrophic for a foundation. And finally, we're replacing those static maps with continuous time mapping. So instead of relying on a single data point from, say, 1970, the system analyzes data over time. This can reveal these crucial patterns, like hidden moisture underground or drainage problems, that you would completely miss with a single outdated snapshot.
So here's the bottom line. When you combine this incredible speed with this new level of precision, what you really get is certainty. And in the high-stakes world of construction and development, believe me, certainty is everything.
And this isn't just a theory. Listen to this. A landscaper who used this service said, "The pH and drainage data saved me from a costly mistake. My margins improved 15%. I mean, that's the power of knowing exactly what you're dealing with. You can bid smarter, you use the right materials, and you avoid those expensive soul-crushing errors.
This basically transforms soil data from a chore into a powerful strategic tool. For real estate agents, it builds trust and helps close deals way faster. For developers, it's all about minimizing risk and keeping costs in check. And for landscapers, it's the key to making sure their beautiful designs actually survive and thrive.
So it really leaves you with a fascinating question, doesn't it? We've gone from waiting weeks for a blurry guess to getting a high-definition map of what's under the ground in seconds. When data can make the very ground beneath our feet visible, what other invisible risks and opportunities is it going to reveal next?